So I have a Lucky shirt, and I've had it for a long time. This shirt actually belonged to my mother, and it's hideous. It's red and white striped, and it's way too big, and it's got all these missing buttons, and it's got like a rip here. I think it's got a soy sauce stain, but I always wear it when I'm working on writing or data analysis, like hardcore, really got to get something done.
Hey, loyal Stereochemistry listeners. It just so happens we're releasing this episode on October 31st, Halloween. And to celebrate this spookiest of days, we've prepared a special episode for you, all about the superstitions of the chemistry community. I'm Carrie Jansen, and that Lucky shirt owner you're listening to is St. Edward's University analytical chemist and CNN advisory board member Rachel Burks. I asked her how it feels when she puts the shirt on.
It makes me feel comfortable. You know, it's my mom's shirt. I've had it for a long time. And it also sets me in to be like, this is serious business now. You know, that shirt means that my mom has been with me in some of the most stressful, high stakes scenarios in my life. I haven't lived at home. You know, a lot of the big kind of things you do in life. So, you know, it's kind of nice that because of the shirt, in some way, she feels like that she was there. So it just puts you in a good frame of mind. It just makes me feel like, okay, it's go time. We can do this.
Rachel told me that, for her, the ritual of wearing her Lucky shirt for high-stakes work, a big project on a tight deadline, for example, is more about stress management than any real belief in the shirt's supernatural powers. And the same goes for another habit of hers, when an experiment is humming along flawlessly in the lab.
Even when something's going well, like you're like, that looks great. You immediately like knock on wood, which can be tricky in a chemistry lab. And sometimes you're like running for the nearest bit of wood. And I joked with one student, I'm like, we should just keep like a 2x4. Just keep it handy so that we always have something to knock on. I used to keep a little wooden figurine on top of the instrument in grad school. And I would just be like, ding, ding. And the thing is, the whole time I'm like, this is kind of not rational, but I can't help it. It just makes me feel, I don't know. I think it's really more stress management on my own part. The instrument clearly is like, I don't care. I'm an inanimate object.
Rachel isn't the only superstitious chemist. More than 20 CNN readers shared their not exactly scientific notions with us for this episode. People who study superstition also use the term magical thinking, and I'm far from an expert. We'll hear from one of those later on, but I did notice some themes in these chemists' superstitions. Generally speaking, chemists' superstitions played out in one of two ways, with researchers performing rituals, or showing some sort of, let's say, deference to magical forces controlling their science or instruments. But no matter which category the superstition fell into, the scientist practicing it usually seemed aware of their magical thinking, and knew it was irrational. So, how does magical thinking persist and play out in the lives of rational chemists? That's what we're going to figure out over the course of this episode, while, of course, sharing some spooktacular stories from our listeners. So pull some splash goggles over your Dracula mask and join me in exploring the superstitions, curious customs, and seemingly magical occurrences in the chemistry world.
The idea is that there are different sets of mental processes in our mind, and some of them work really fast and efficiently, and some of them are more slow and deliberate. They require our sort of active engagement.
That's Jane Risen, who studies magical thinking and decision-making at the University of Chicago. She explains that superstitions fall into that fast, efficient category of mental processes. For instance, a person wins bingo for the first time while holding their troll doll, and their brain makes a fast connection between the two things. The troll doll becomes lucky. But understanding how something actually works happens on the more slow and deliberate side of mental processing. Risen said that once the slower, more deliberate process kicks in and recognizes an error in that fast intuition, it can correct it, but not always. And that's how superstitions survive, even in otherwise logical people.
When you think about the fact that the superstitious intuitions are going to be provided by this very quick and automatic system, it helps you understand why it's so easy to follow them. Our minds are built for recognizing patterns, sometimes even when they don't really exist, and so it's easier to see them than it is to not see them, oftentimes. And especially when you add in things like stress and uncertainty and tension.
Jane says that pressures may run highest when scientists start a new project. When things work especially well, or don't, the brain looks for a simple, fast explanation for the outcome that may be completely unrelated. And sometimes a particular ritual can become so embedded that facing the task without it starts to feel uncomfortable, Risen says. That seems to be the case with this next story, which comes from Samantha Jones, a production editor here at CNEN.
I was kind of taken aback by how ridiculous this whole situation was.
Sam was a few months into the first year of her PhD at UC San Diego, working in a molecular biology lab on a project to label specific messenger RNAs in mouse brain tissue to try to gauge what genes are being expressed in the brain and where. It's there that Sam observed a surprising custom from her coworkers. The team would lay out hundreds of microscope slides, each containing 4 to 8 slices of whitish, cloudy mouse brain tissue. They'd place the slides inside boxes, brain side up, then add a few drops of a solution containing a probe that would react with particular RNA molecules and turn the brain tissue blue or purple. They hoped to see clear areas of concentrated staining, but it was easy to end up with too little or too much color, obscuring the results. After dripping the solution onto the slides, they'd close up and carefully stack the boxes, one on top of the other, inside a large plastic tub.
And so then that tub was left to incubate overnight, but not before putting a paper towel on top of the stacked slide boxes just below the plastic tub's lid. So 15 slide boxes, hundreds of slides, one paper towel. Was it to keep in moisture? No. Did it help stabilize the stacked slide boxes? Nope. And so when I asked if I could just not add it, members of the lab looked at me like I was insane. It was like, oh, of course you need to keep that paper towel on there, always. We always do. And so then I was told that I could go ahead and remove it, but then if the experiment failed, it was on me. And so the unnecessary paper towel lived on.
And did you ever consider taking your chances, just not doing the paper towel and just seeing what would happen?
I was only a few months into grad school and I was already a little freaked out. So I just figured better play it safe on this one and not frustrate anyone in the lab where I was rotating. So I did not, but I would have loved to have done it and had it work.
Sam never learned the mystical reasoning behind that single sheet of paper towel, but she did say the lab had around a 50% success rate with this particular experiment, which is higher than the roughly 30% success rate you would expect. Like I said, getting that color reaction just right was a tricky task, with or without the help of a supernatural paper towel. These examples from Sam and Rachel illustrate one of the reasons people use superstitions, according to Jane Risen, to create good luck. But Jane tells me that they can also be intended to reduce bad luck. Like in this example from Rebecca Cuellar at the University of Minnesota's College of Pharmacy, which she shared in the form of a poem.
3 mistakes or 3 things break, a lab timeout you must take, lest more errors you will make.
Becca says her 3 strikes you're out rule is inspired by her childhood love of baseball, and it comes with a somewhat complicated rulebook of what counts as a strike.
Broken glassware is an immediate strike. There's no question on that one. If you've spilled something that's valuable, that's another strike. Now, if you have something a little bit more major, say you broke a column and not just a disposable test tube, that's going to probably get you 2 or 3 strikes immediately. Towards the end of my graduate school time, I spilled a couple of column fractions that had very important, I don't remember if they were penultimate compounds, but fairly close to the end of my total synthesis. And so there were cotton ball benchtop extractions that were involved to recover from that.
Is that a technical process, the cotton ball benchtop extraction?
Highly technical. Cotton balls, sopping up the liquid. Perhaps there are tears mixed in with the solvent, and then rinsing them in a funnel. If that was a first strike, I'm going to go ahead and call 2 and 3 right on top of that and, take a break.
Becca says that although the number of 3 is kind of arbitrary, forcing herself to take a break after strike 3 has turned out to be a healthy practice, and she believes it helps ensure quality and safety.
I'm a mom now, so we use timeouts as a form of not just punishment, but also just a moment to regroup and kind of think about what you've done and perhaps analyze what could prevent that from happening again in the future. If one's making mistakes in the lab, like multiple mistakes, especially the kind of silly ones or clumsy type of ones, it's either because maybe you're too tired or perhaps your head is just, thinking about other things, in which case maybe you should kind of go deal with that before focusing on the lab work again.
Whether it's taking a break after 3 strikes, paper toweling your experiment, or wearing a lucky shirt, our behavioral scientist Jane says that even the silliest of rituals may actually have a benefit.
What we find is that the people who engage in the ritual end up performing better on the task. And they perform better on the task because they seem to be less anxious. So I don't think it's a direct effect, right? It's not that the ritual has somehow magically changed how you perform, but we can sort of document the indirect pathway by which engaging in this ritual changes your heart rate, changes your self-reported anxiety, and those people are the ones who end up performing better, specifically in high anxiety situations. Now, interestingly, what I just described is true regardless of whether people believe that the ritual is effective or not.
After the break, we'll move on from rituals and take on the superstitions regarding the science and the instruments used to perform it. We'll hear about Jedi-like principal investigators and discuss the wisdom of threatening your lab equipment in just a minute.
Hey there, I'm Raj Mukhopadhyay, Executive Editor of CNEN Brand Lab. You've read about CNEN's newest class of Talented 12 Rising Stars in Chemistry. Now, you can hear these remarkable researcher stories in their own words in a collection of videos recorded in August at the American Chemical Society's National Meeting in Boston and now available on CNEN's website. You can view them at bit.ly/T12Vids2018. Harvard University's gene editing guru, David Liu, opened the session by offering advice for young professors.
There is a tendency to implicitly or sometimes explicitly try to convey to our trainees that their highest goal, their highest aspiration should be to grow up to have just the same profession that we have. In other words, to clone ourselves. And instead, I think our highest obligation is to serve as a matchmaker, both of the science that we do and of the careers that our trainees hope to launch.
You can also watch our honorees explain the whys and hows behind their work, like this story from genome fixer Nicole Gadelli about an early lesson in critical thinking from her grandfather.
We were out on an especially cloudy day, and I asked him, "Where's the sun?" And he said, "Behind the clouds." And I said, "Well, how do you know that?" And he said, "Well, you don't need to take my word for it." And so we sat on the front lawn, laid on our backs, and watched as eventually the sun came out.
And a little bit of inspiration from materials maven Kathy Moltzer.
So it's really easy to get caught up in how technology is going to make our lives better and faster and more efficient. But it's really important to not lose sight of the people that are driving each of these innovations. And it's really up to the innovator to craft what that picture of tomorrow is going to look like.
Again, videos from the Talented 12 Symposium are available at bit.ly/T12Vids2018. We'll also post that link in this episode's description. And now, back to the show.
We just heard from chemists who use rituals to improve confidence in their work, but many chemists also hold to some magical thinking about the instruments they rely on, ways to increase the chances of a positive result perhaps, or explain unexpected results. Rachel Burks, the analytical chemist I spoke to at the beginning of this episode, sometimes goes to great lengths to shield her lab instruments from negative influences.
You never talk bad about instruments in front of the instrument. I will literally walk away from the instrument or walk out of the room with a student or by myself and then talk bad about the instrument. It's like, don't let it see that you're frustrated. Don't let it see that you're angry. Just say nice things to it. In graduate school, I would go out in the hallway and say to myself, it's lucky that window doesn't open or that instrument would have gone out the 7th floor. I don't communicate that to my students. I don't have a rule like you can never talk bad about an instrument. But when I'm around the instrument and the student might say something, I'm like, shh, don't say anything. It can hear you. And they just laugh at me because they're like, okay, Dr. B.
But where Rachel does her best to be nice to her instruments to ensure good results, when John Burkaw, professor emeritus at Caltech, was synthesizing organometallic catalysts, he would take a different approach.
I often work at a high vacuum line because a lot of the reactions I carry out are with compounds that react with air, often violently. So I have to keep air away. So I work on vacuum lines and I'm doing a new reaction and I'm very anxious for it to give the color change or some indication that the reaction succeeded. So I used to have a ball peen hammer. I don't know if you know what those look like.
Yeah.
Okay, well, I used to place one on the shelf right next to the reaction while it was going. And I would tell the reaction, you know what I'm going to do if you don't give the result that I want, right? But in many cases, when I threatened it like that, it actually performed. It would have performed anyway, I'm sure. Yeah, I never had to smash my flask off of the vacuum line with the ball peen hammer.
But as far as lab superstitions go, threatening his labware is not actually the eccentric notion John is best known for. There's another idea that he popularized in the Caltech chemistry department decades ago. It's called Birkhaugh's Law of Initial Optimization.
Yeah, I'm sorry it's called Birkhaugh's Law. I don't like to call it a law. It's an observation.
Birkhaugh's observation of initial optimization notes that a newly discovered reaction or structure often performs best the first time around, which is too bad, considering the next thing most chemists do is try to improve the system.
You make many changes with great painstaking care, and everything you try after the initial optimization makes it worse, not better. Sort of a nasty trick that nature plays on us to put us in our place. My conclusion. It's sort of a cruel trick. And so everybody, when they realize that they've made all these changes and the first thing they ever tried is still better than any of the new versions, naturally they get discouraged and sort of bummed out, and then they think of my name. I think it's often seen when we are studying a catalytic reaction and we discover a catalyst that does, in some cases, it does something totally unexpected and new. And my rationale is that the very best catalyst is going to stand out more clearly than inferior catalysts that might not even get your attention to start with.
How do you feel about that fact that your name is the one that comes to mind when people are having just a very frustrating time with their work?
I laugh because I didn't create it or impose it on anybody. It just happens. And I noted it. I suffered it myself, and then I talked about it. It's not always true. I always cheer when somebody says, well, we made this change based on understanding this feature of the reaction, and it made it better. And occasionally, even I've done that. And so that makes it all the better.
I asked John why he thinks chemists latch on to these ideas about strange, unnatural forces at work in their labs.
I think it just makes life more fun. I think that scientists tend to be very conservative and skeptical and want very rational explanations for the observations that they see. And that gets to be pretty dry. So anything that'll spice it up a little bit, I think, is attractive to us.
I asked the same question of CRO, the dog who blogs, as he calls himself in internet chemistry circles. This mysterious chemist blogs under a pseudonym to talk candidly about the chemical enterprise without jeopardizing his professional status and reputation. And he offered a different explanation for the source of laboratory superstitions.
I think that when you're first starting out and things seem a little bit scary, you're not entirely sure of how to run a reaction properly, what you can do with certain pieces of equipment, whether you can run that gel for a longer time or not, whether that particular solution is stable, do you need to refrigerate something, etc., etc. And over time, you learn that, and you learn these variables are critical. But I think that when you're in your first and second year of graduate school, things seem a little spookier and more superstitious until you learn more about what actually controls them.
CRO told me he's witnessed many lab superstitions over the years, and in particular, he's noticed an odd custom around lab equipment used by researchers who went on to become famous and well-respected chemists.
A lot of times, there'd be a residual feeling about their hood and their lab equipment, their glassware, their notebooks, that somehow that led to the success of this particular person. It's probably not true. It's probably the case that this person was just talented, and it happens that, like a famous cowboy's hat or philosopher's stone, you think more about that object because of the person who held or owned it. But I think that there are definitely people who say, wow, that's Nick's old column. He's doing great at Merck, so maybe you'll get great results on it. Or that's Jen's old notebook, and now she's at Cornell. Maybe you'll also have her success.
I wanted to know what effect these magical items had on the grad students or postdocs using them.
It's probably chicken and the egg. You don't know, is it the legend or the spin that the professor and the older postdocs are putting on the thing that bring a person up to a higher level or bring them up to a higher standard of performing? Or is it the case that that person was talented, and so it just happens that the next person in line was recruited because of that talent?
And like the aura of success that seems to linger after a notable chemist has departed, there's another mystical force seemingly affecting chemistry grad students and postdocs.
I had heard about it from older researchers when I was doing my undergrad, and then I only began to experience it myself during grad school. I've heard stories from people really all over.
That's Julian Silverman, a postdoc and teaching fellow at the University of Kansas. Julian studies soft materials made from waste and biomass that could replace petroleum-based ones in consumer products. And during these studies, Julian's witnessed a mysterious phenomenon.
So it's kind of like when you have a problem on your computer and then you call tech support and it goes away, but then you hang up and it comes right back. But it's actually the opposite. It's where your experiment is going fine and then your PI comes in to look at it and it magically stops working until they leave. And we had always called this the PI negation field.
And the field itself isn't the only supernatural part of this superstition.
It's sort of magical how it's very reliable. You can always expect your experiment to stop only when your PI is in the room.
Have you tried anything to counteract this effect?
So I find it's more about mitigation. So it's like you either undersell the project until the PI comes in, you try to get them not to get very close. I think the real question is whether or not the PIs are aware of this, because in theory, they've seen it themselves when they were grad students. But the theory is that a PI can actually learn to sort of hone this skill, kind of, I guess, like the Force in Star Wars.
And like any compelling theory, this one is going to need more research to back it up, Julian says. Who do you think should be the scientists or the field of science that should take this on? I mean, are we talking like physics here or?
I think it's very interdisciplinary, which is why it's very good for sort of, modern grants and stuff. There's probably some physical background to it, but maybe a chemical solution, with shielding or, I'm not even sure, but I guess we'll see, hopefully.
If any of you want to help Julian get to the bottom of the PI negation field, it sounds like you'd be doing a serious service to grad students and postdocs the world over. With all of this talk of good luck rituals and magical explanations for professional setbacks, I wondered about the place of superstitions in scientific work. So I asked Jane Risen, the behavioral scientist, if she thought scientists should do away with silly superstitions.
Do you see that as something that ought to be corrected?
Unless your superstitions are getting in the way of you functioning in the world or getting in the way of other people functioning properly in the world, it's probably not enough of a problem that I would recommend sort of trying to get rid of them entirely. Think about how, when you're making these kinds of calls, you want to limit the costs that come from either. So if you're following your intuition, you want it to be that the costs of ignoring rationality are not too high. And if you're going to follow rationality, you want to make sure that the costs of ignoring your intuition are not too high. And so, generally speaking, I think it's a fair decision to follow what's rational, but I don't think you have to all the time.
Big thanks to chemists Alex Miller and Alex Goldberg for cluing me into Burkhardt law, or observation, and to CRO and blogger ChemJobber for helping us collect superstitions, and thanks to everyone who sent us their stories. If you have a chemistry superstition you'd like to share, email us at cen_multimedia@acs.org. We may share some on CNEN's website. And don't forget to subscribe to Stereochemistry. We'll have a new episode for you in time for Thanksgiving, if you're in America, and in time for the fourth Thursday in November, if you're anywhere else. The music you're hearing now is Moonlight Hall by Kevin MacLeod, and our ad music was The Confrontation by Poddington Bear. Thanks for listening. You still there? I couldn't end the episode without this parting word of spooky advice from CRO, for those of you who run thin layer chromatography.
TLC plates work best in rectangular shapes, never cut squares.